Here, dear, have a cup of coffee.
Thank you, I think I will. Well, that was great. Suppose we're going to build a rectangular box. Fancy name for that would be a rectangular parallelepiped. Underneath the slanted piece of roofing. The equation of the slanted roofing can be represented as 6x plus 4y plus 3z equals 24. If you'd like to see the plane, it's here. Notice that the x-intercept when y and z are both 0 would be x equals 4. See it here. And the y-intercept when x and z are both 0 would be y equals 6. Out here. It's a little bit off my graph, but that'll work for you, I think. And the z-intercept when x and y are both 0 would be z equal to 8, and I think you can see that on here. And what I drew was a little purple box underneath that slanted plane. And we want to make the maximum volume box with one corner at the origin and the other corner on that plane, so that it would fit underneath that slanted piece of roofing. So the volume of the box is length times width times height, and that's pretty easy to see what that would be. It would be x times y times z. But if we solved this equation for z, we can come down to a two-variable function, and z would be, well, let me see, 3z equals 24 minus 6x minus 4y, so z equals 1/3 of 24 minus 6x minus 4y. So our volume for the box as a function of x and y, volume as a function of x and y, would be 1/3 of x times y times 24 minus 6x minus 4y. And if you simplify that by distributing the multiplication, you get 8xy minus 2x squared y minus 4/3 xy squared. The graph of the plane is shown here with the purple box under it. I think you can see that clearly. That might not be the best purple box, by the way. It might be a little bit bigger in the y direction than the x, but I just thought I'd give you what's a picture of what we're talking about here. Well, the partial with respect to x of our function of two variables here, which maybe I'll bring down here so it's easier to see. Partial with respect to x, 8y minus 4xy minus 4/3 y squared. So there's the partial with respect to x. The partial with respect to y is 8x minus 2x squared minus 8/3 xy. So there's that. This can be factored. I don't know why I can't get that to disappear there. I'm trying to get that to disappear, but I guess it doesn't matter if you understand what it's saying. We're okay with it the way it is. There, now I got it the way I want it. Factor of y out of the numerator and of the partial with respect to x, we'll get y over 3 even times 24 minus 12x minus 4y. And factor in x over 3 out of the numerator of this one, we get x over 3 times 24 minus 6x minus 8y. A few things to note. This partial was 0 when y is 0, and this partial was 0 when x is 0. And x equals 0, y equals 0 is, in fact, a solution, but I think it's kind of obvious that would be the minimum volume box because one corner is at the point 0, 0, and so is the other. Not much of a box. But to look into other solutions, then 24 minus 12x minus 4y equals 0, or 24 minus 6x minus 8y equals 0. I guess if we set this a little different, it would be 12x plus 4y equals 24. This one would be 6x plus 8y equals 24. So solving this system simultaneously, we can get to the solution x equals 4/3, y equals 2. You know, solving this equation equals 0, this equation equals 0. I don't think I need to go about showing you how to do that, but algebraically you should be able to solve that without a problem and get 4/3 2 with another critical point. Well, 0, 0 is certainly a minimum. And so now the question is, what is this? And right now I want to guess a maximum, but I don't know that for certain. But I can tell for certain if I look into the second partial. So the partial derivative of this function with respect to x is just negative 4y. The partial of this one with respect to y is negative 8/3 x. And then the mixed partial of this one with respect to y would be 8 minus 4x minus 8/3 y. And of course that should be what this is too. Partial of this one with respect to x, 8 minus 4x minus 8/3 y. So they're both the same. And now if we plug in the point x is 4/3, y is 2, then we've got the partial with respect to second partial with respect to x times second partial with respect to y at that point minus the mixed partial at that point, which would be negative 8 times, well, at this point we would have negative 32/9 minus, putting in this point, we'd have 8 minus 16/3 plus 16/3, so sorry, 8 minus 16/3 minus 16/3, so that would be 24/3 minus 16/3, 8/3, so although I have it as minus 8/3 squared, I guess either one, if it's minus or plus, it doesn't make any difference. I'd be squaring it anyway, so we got this minus this squared, and that comes out of 64/3, and our second partial with respect to x evaluated here would be just negative 8 at that point. So that point does yield a relative maximum. Therefore we should construct a box with one corner at the origin and the other at x equals 4/3, y equals 2, and if you figure out what z is at that point from recall solving this equation for z, we had 1/3 times 24 minus 6x minus 4y, so z at that point would be 8/3. That way we have a maximum volume of 64/9.